Okay. Can you guys hear me now?
Yes.
Yes.
Miss Noha,
Okay.
may I answer?
May
Okay,
I
you
answer?
answered before. Just guys, give me a second, okay? Just check. I'm checking if you can hear me well and if you can see the screen well.
Okay.
Can you see the screen, or can you see me sharing the screen?
Yes.
Okay, that's good. And I believe you can hear me well now. Okay, so I had
Yes.
two questions. The first question was the types of electricity, and Rugmini answered. Can you answer again, Rugmini, please?
Current and
It's
Yes,
the type of
Rugmini.
electricity.
Yes, the types of electricity. Static and
Okay. Static electricity and current electricity.
yes, static electricity and current electricity. Well done. Thank you so much, Rugmini. And static is the one that builds up on objects, while the current electricity is the one that needs to move through wires. The last thing we learned about was circuits, if you guys still remember, and we said that we need components to build up a circuit. Now we have some people to answer this question. Okay, Reem, you can tell me only one component. Okay, I think Reem didn't want to answer this one. Muhammad, you can tell me one component we need to build a circuit?
Okay, a buzzer.
A buzzer? Did you say a buzzer?
Yes.
Okay, that's interesting. Thank you so much. But we can say some other components that we still need. Jumana, you can tell me another one.
Batteries.
Batteries, which are the source of electricity. That's right.
Yes.
Okay, Farah, you can tell me another component.
Miss, can I answer?
Yes, Farah?
Wires.
Wires. So, like Jumana said, and thank you, Muhammad and Farah. So we have batteries, wires, and then we have
Miss, can I
something
say
to
something?
show. Yes, Farida.
We can. Are you talking about the static electricity or the normal electricity?
I'm talking about the current electricity. We were talking about the circuits, saying that we need components to build up a circuit. And your friends shared some of their components.
Yeah.
Yes, so in order to build a circuit for electricity to move through, we need wires, we need batteries, and then we need what to show us if there is electricity.
Miss, light bulb.
Well done, Faida. Yes, so we need a light bulb. Thank you so much. Okay, so in order for a circuit to work, we also need the circuit to be complete. Okay. Let me share right now with you. Okay. For example, all these circuits and all these circuits in front of you guys, only one will work. Can you remember which one?
Yes, may I answer?
Okay, Rugmini, you answered a lot of questions today. You want to answer a lot of questions today. Okay?
Miss,
Just pick someone else that didn't answer. Okay? Okay, Rugmini, so we can give another chance for your friends.
Miss, no, can I answer?
Okay, Rugmini?
Miss, can I answer?
Okay.
Thank you. Guys, don't say, can I answer? Raise your hands. I'm going to pick people raising their hands. Okay? Okay, Abdurrahman, yes, you can tell me. Which one will work?
B.
B, yes, because it's the complete one. Others are not complete. Like in A, it's not complete at all. In C, there is a gap in here. Do you know what a gap is? It's like a space of air. Okay? Electricity will not be able to move through it. It needs to be complete. And also D is not complete at all. Okay. So a complete circuit, for electricity to flow in a circuit, it must be able to flow from one end of the battery to the other end of the battery, right? So that's why it needs to be connected with wires. Like all of the circuit needs to be connected with wires. Okay? Okay. Electricity doesn't always only to use wires. What does that mean? Okay, we have some materials that can actually let electricity move through them. And we call these matters conductors. So we have something, a new term today. It's called conductor. What is a conductor? It's a material that allows electricity to move through it or to flow through it. How can this happen? For example, let me show you something. Just let me get to it. Okay, so for example, this is how the wire looks like from the inside. Okay, so I took the white coverage or the plastic coverage over the wires, and this is how it looks like from the inside. This is actually a conductor. Conductor is a metal or material that allows electricity to move through it. Okay, what kind of matter do we use or do we need? So let me skip all of this and get to this point. Okay, so in here, we have different materials. As you guys can see, we have copper, pure water, solid water. We have solid solution, I mean salty solution, and we have only salt. Okay, so we have different materials. Some of them, not all of them, will allow electricity to move through them. Okay, so here we have a simple circuit with a battery, a bulb. You guys see battery and the bulb. We have a switch. Okay. We need the switch for what? Okay, let me pick someone to tell me what do we need the switch for? Okay, we have Leila. Leila, can you tell me why do we need a switch for the circuit?
Yes.
Yes, Leila.
Yes, Miss Na.
Yes, Leila.
So can you ask the question again?
I was saying, why do you think we need a switch for the circuit? Like, why do you need the switch to be on and off? Why do we need to add a switch to the circuit?
Because when there's a electric is that is connected to the bulb or the thing, then it goes off and on.
Okay. Thank you for
I mean,
sharing your ideas. But do we have some other words to use? Like, can we pick someone else? Okay, like Reem. Yes, Reem. Why do you think we need a switch
Okay.
for?
To power to let the circuit work.
Okay, that's nice. So it can let the circuit work. We can say it's also to control the circuit. So we can control if it's going to work or not, right? So for example, when I press it on, that means it's supposed to work. When it's off, now the circuit is broken, so it's not going to work. So let's try some materials and let's see if it's a conductor or not, okay? What's a conductor again? Jenna, can you tell me what's a conductor again?
Yes.
Yes, Jenna?
A conductor?
Yes. What do you think a conductor is? You can say it in your own words. We just said what a conductor is.
It connects the
Yes.
batteries. Connects.
It connects.
The
Nice. Yes. So it can allow electricity to move through it. Okay?
Yes.
Okay. If you guys check this circuit, I just pressed the switch on. So that means this circuit's supposed to work. But it's not working. Why isn't it working, Muhammad? Why isn't it working?
Why does it
circuit is not
doesn't
working?
work?
Because what?
I think because the string is too thin for it.
No, actually the string or the wire, it's not string. It's actually fine.
Miss, can I help?
Okay, Jumana, you can tell me.
Because there is a gap.
Yes, there is a gap in here. Muhammad, can you see it? Just there's a space in here. So if electricity moves through the wires, it will actually meet this gap and it will not be able to move into the rest of the circuit.
Miss,
Okay?
I have a question.
Yes, Muhammad.
What are these?
Those are clippers. Clippers, they work as wires. So when
Okay.
we can connect
We use
them
it in the
to
class.
batteries, we can connect to them, and we're using them in here so we can check different materials.
We used it in the class while we were doing
Yes.
Miss, I want to tell you something.
Yes, Hamza.
When I was in grade 3 last year,
Mhm.
me and Mustafa went to Smart Peak. So we used like objects like the conductors and batteries and LED light,
Nice. You and who?
and we connect me and Mustafa.
You and Mustafa Sulaiman?
No, Gab.
Oh, Mustafa Gabu. Yes, I miss him so much, wallah.
Yes.
So missed. That's nice. So you really
Mm.
know those.
Miss,
Yes.
Yes.
Miss, can you
I
try
used
the
them like a
copper?
year ago.
Can I what, ya Leila?
Can you try the copper?
Can I? Okay, yes, I'm gonna use them now. Okay. So guys, now we're gonna use different substance and see if they are conductors or not. So let's start with the copper. The copper. This is a metal. We all know it. So let's add it here and then let's switch on. Oh, can you see that?
Yes.
Yes, so now it's working. So that means this copper is a good conductor. Can you see the word? Good conductor. What does that mean? It means that it allows electricity to move through it. Okay?
Okay.
Okay?
Okay.
Yes. Okay, now let's pick something else. For example, let's pick the pure water. Of course, we're not going to use all the substance. We don't have enough time for that. So if I used pure water instead of the copper,
I think it
and
won't work.
what do you think? Is it going to work or not?
No, I don't.
No.
Okay,
No.
some people saying no.
No.
Okay, let's switch it on. Yes, it's not working. Why
Yes,
is
it
that?
works. Because it's liquid.
Not because it's liquid.
Doesn't have many charge.
It won't work. It's just pure water
It
doesn't
doesn't have.
actually connect electricity together or conduct electricity. So it's not a conductor. Okay?
Did the copper work?
It's not a conductor. Now let's
Miss, I
try.
think it could be underwater.
You think
Let's
what?
try it.
Miss, try the plastic coil.
Okay, before the plastic, guys, just give me time, okay? Before
Okay.
the plastic, let's try salty water. Salty water is the NaCl solution. This is chloride, which is the salt. Let's
Miss,
try salty
Miss,
water.
I think it will work.
Yeah, it will work.
Miss,
Okay, people
does
are
it
saying it's
connect
gonna work.
underwater?
Yes, Yalila, what are you saying? Because I can't hear you well.
Does it connect underwater? Miss, I think it will not.
No,
It
we're
will
just
work.
I think it
making
will.
two clippers touch
It
the
will.
bottom.
It will.
I think it has
It
more
will
charge.
work.
It has a lot of
Okay,
charge.
people saying it will work. Yes, it will.
Yes, it does.
Because it has salt
It
and
has
salt
many
is
charge.
mineral.
Yes, well done, because it contains salt, and salt actually allows electricity to move through it.
Any
But
mineral
this
could make
happens
it
only
work.
in the salt with water. Like if I used NaCl, which is the normal salt, the solid one, it's not gonna work. See? It's not gonna work. See? So only
Yeah.
salt with water will be able to conduct electricity.
Yes,
Now
because
let's
salt
try
will be
something
dissolved.
solid like plastic. Are you interested to
Will
try the
work.
plastic toy?
Yes, it will work, I think.
The plastic toy will work?
It will
It will not work. It will not.
Okay,
I
some
hope
people
not.
saying it's
I
gonna
think
work,
yes.
others saying it's not
It
gonna
will
work. Okay, let's try this.
No, it
No,
will
it
not
will
work.
work.
On. Oh, it's not working.
It did
It's
not work.
not conducting electricity. What do we call the materials that do not conduct electricity? We call them insulators. We call them,
Insulators.
yes, like the word you guys can see
Because
here,
it's just
insulator.
plastic.
So today we learned two new words,
Let's try
conductors
iron.
Conductor and insulator.
and insulators. Yes,
Let's
conductors.
try iron nail.
Leila,
Iron
Leila,
nail.
Leila.
Yeah.
Habibti, yes, we will try different materials, but now you need to understand what do you mean by conductors and insulators. So conductors are again materials that allow electricity to move through them. Like for example, iron nail. Let's try the iron nail instead of the plastic toy.
It will work.
Anything
It
iron
will
will work.
It's gonna
It
work,
will.
yes.
It's
So
gonna
that
work.
means, okay, that means that this iron nail is a conductor. It allows electricity to move through it. But
Miss,
if
no
I
could
used the wood, for example, is
no,
it gonna work?
it won't work
No.
because it will catch on fire.
It will not work, yes, because wood is actually an insulator. It doesn't
It
allow
can,
electricity to move through it. Okay?
Miss, it can cause fire.
It can cause fire. Yes, it has a
It
lot
can
of.
burn.
Okay, what
Glass will
about
work.
glass?
Glass,
No,
it will not work.
It
I don't
won't
think
work
so.
Not
too.
work.
So what is a glass? Is it a conductor or insulator?
Insulator.
Yes, thank you. So let's try sugar solution. It means sugar with the water. It's gonna work?
No.
It will work. Yes.
Can I be?
I think
Okay,
it
some
No.
are
will.
saying it will, the
No.
others are saying no. Yes, it will not. Only
And
salt with water will work. So we have different materials. So now we know, you know that we have different materials. We have conductors and insulators. Conductors are the materials that allow electricity to move through them, while insulators don't allow electricity to move through them. Okay?
Okay.
Okay, do you get it now? Do you get the difference?
Yes.
Okay, so again, what is an electric conductor? It allows electricity to flow through it, while an electric insulator does not allow electricity to flow through it. Can you guys give me examples of conductors?
Conductors.
Yes.
Conductors. Iron ore. Copper. I mean.
Okay, so
Copper and nail.
copper, iron,
Nail.
water with salt.
water with
MACLE.
salt. Yes, well done. Okay, now give me an example of insulators.
Wood.
Wood.
glass.
Plastic.
Wood.
Boy.
Glass.
Yes, I heard most of your answers.
Plastic.
Wood,
And
plastic,
glass.
glass, yes.
Plastic. And plastic.
Sugar
Toy.
solution,
And plastic.
solid salt. Yes, so all of those are
Plastic.
Plastic toy.
plastic toys. Yes, plastic is actually a good insulator. It doesn't allow electricity to move through it at all, and that's why we use it as a coverage for the wires. You know, the wires are all covered with this plastic coverage that protects us or our hands from being electrocuted. So in here, if we went to the lesson, let me get to this point where I want to
Miss, I'll open
show
my book too.
you. Yes?
I'll open my book too.
Oh, that's nice. Well done. So for example, in this picture, we have this nice picture of different wires, as you guys can see. You see this outside coverage? Can you guys see it?
Yes, it's
Yes,
plastic.
it has this outside coverage, this one big,
It's made out
a
of
small one.
plastic.
Those are made up of plastic. Yes, well done. And those are insulators. So when we touch a wire, we don't get electrocuted. While the inside of the wire, this part, the inside part, it's actually an conductor insulator.
Conductors, yeah.
Conductors, yes. So it allow
It
electricity
will
to move them.
electrocute you.
The what?
It will be like electrocute you.
Yes, they will
Shock
cause
you.
electricity through our
Yeah.
bodies, and this is so dangerous. So we have this clipper. I really don't know what do we call this one. This one that's used to cut wires. This tool.
But I'm gonna do something
Okay.
fast.
This tool, for example, this part I'm highlighting. This part is made up of metals, and metals are really good conductor of electricity. So if I try to hold it from this metal part, I will actually get electricity or get electrocuted. That's why they added this plastic blue coat. Can you see it? This is
Yes.
actually rubber. Do you know the rubber?
Yes.
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 They added rubber to its hands so I can hold it from the rubber part and don't get electricity through my body. Now we get it?
Yes.
Yes. Now you get the difference?
Miss, one time my cousin tried to put the wire and the battery together and the light bulb just lighted.
And the light bulb did what?
Lighted.
Oh, that's nice. Well done. Okay. Now we said that we have two different types of circuits. A circuit is where the electricity moves through. Like it must contain a battery, wires, two bulbs. Okay.
Miss, she tried it like that.
You tried it like that? Well done.
My cousin.
That's
Miss,
nice.
this is the thing that you gave us yesterday
Yeah,
in
it's
the
like
science session.
yes, it shows
Yeah,
you the thing.
and we tried to like click it and like not click it, like put it on the part, like not to electrocute us.
Yes, that's
All
right.
Yeah,
of
miss,
us
and
got
when you give us this thing like in our group, we try to put like the one wire into the battery, like into the battery.
One
So it
side of the battery.
you know the this wire. Yesterday you give us like two wires,
Yes,
right?
yes,
So we took one wire and put it in one wire, and we put it in both sides in one wire,
yes,
and it came out of it like some like red sparkles or wabasat fire.
yes. That's so dangerous, actually.
Miss
Yes.
Naha, all of us got shocked.
No, you didn't. You were just holding it in a wrong way. I told you guys to not hold it like that. Okay,
Now all
so
of
let
us.
me show you something in here.
Miss
I
Noha,
think
So again, we have, guys, please now mute yourselves because I'm hearing some noises. So now we have this circuit. It's a simple circuit with a battery, wires, and two bulbs. This what we call series circuit. Series circuit, okay? Now let me mute you guys because there are some noises up there. So this series circuit means that there is only one path for electricity to move through. Can you see how electricity is moving into one path only? Can you
yes.
see that? Yes, until it just goes back to the battery. So if there is a cut somehow in this battery, if there's a cut or a gap in this battery of somehow, it's supposed to turn off, right?
Yes.
Yes. So here he's showing you. Let me show you what's going on here.
Now it's not complete.
See this one? When we added the gap, now electricity will not be able to move. Can you see that? Can you see that, guys? Now electricity will not be able
Yes.
to move through it, and that's why it's all broken.
Yes.
None of the bulbs are working. And we said we want to draw this, we have to use samples. So if I wanted to draw the circuit into simple diagram or simple picture, I would use those. So let me take them all off. Okay, so this sample is for the battery. Remember, this one is for batteries. These represent the two bulbs, and the wires is just a simple straight line. Okay, now you can see that the battery only has one way to move. I'm sorry, the electricity has only one way to move through, and that's why we call this series circuit. So in series circuit, how many paths do electricity have? How many paths electricity have in the series circuit?
Uh, one, five,
Only
four.
one. Yes, only one path. And if this path gets, interrupted by somehow a cut, a gap, one of the bulbs broken, actually the whole circuit will turn off. Okay? Now, if we look to the other type of circuit, let me get to it.
Miss
Where is
Noha,
it? So here
Miss
we
Noha.
have two bulbs and also batteries, but we have two different paths. So if I try to see what path the electricity will follow, I will get an arrow in here. Okay, and here is the battery, starting from the battery, moving. Can you see that? Now the electricity have
Yes.
two paths to move through, and then it moves back to the bulb. So if it's broken by somehow, if one part is broken, what happens? Is it still working?
Miss, could I ask you a question?
Yes, Hamza.
Which wire is the negative and which wire is the
The positive?
yes?
Negative, minus,
Well,
and
it's up to the
positive.
battery itself. I mean, which part is
No,
positive and which part is negative? And the
yes.
charges actually move from the negative part to the positive parts. So it's only
Because
the
it's
negative that is moving, not the positive. You get it?
in smart peak, the if the wire is
positive or negative.
Hmm?
It depends on its color.
Well, the different
That's
colors
what I
is
think.
just to show you different paths. But if the electricity is working, it means that the negative charges are moving from one side of the battery to the other side. Okay, so the positive are not actually moving.
Okay.
Get it?
Yes.
Yes. So in this circuit, as you guys can see, now we have a break in the circuit where one pulp is not working, but still the other one is working. Why is that? Because now this parallel circuit has two passes for the electricity to move through. So what is the big difference between parallel circuits and series circuit? It's that the parallel circuits have many paths for electricity to move through. So if I took all of these wires off, and started making new ones, you will see that electricity is moving this way. Guys, please mute yourselves because there is big noise back there. Thank you. Thank you so much, Hamza. So now
I
the
think
arrows
it's my
are
buzzer.
showing you how electricity is moving. So when it comes here, the electricity have two paths to move through. See that? So if one path is broken, the other one is still working. Do you get it? Do you guys get the difference?
Yes.
Yes. So today we learned different things. We learned that we have two types of electricity as last time. We learned that from last time. And we have conductors and insulators, if you guys remember. Conductors are organisms that, I'm sorry, organisms. No, they're not real things, not living things. I'm sorry. They are materials that allow electricity to move through them. Okay. And insulators are materials that do not allow electricity to move through them. Okay. And we also learned about different types of circuits. So we have parallel circuit and series circuit. Okay. The series one is the one with one path only, while the other one is what we
Miss, your
call.
voice is lagging.
Guys, can you hear me now?
Yes.
Okay, I
Your
think the internet
internet.
connection is
Yes.
unstable.
Yes. Yeah. Yeah.
Yes. The internet connection is unstable, unfortunately.
Yeah.
Okay, so now I need you guys to build me a battery. I'm sorry, a circuit. We'll drag things from here. So to build a simple one, we need.
Miss me, please.
Miss, could I answer, please?
Okay, just let me show you a simple one.
Okay.
I know
We
how
add
I can do it.
wires. Okay. Why isn't it working this way? Can we use this one?
Maybe yes, maybe you need this one so it can like go down.
It was working with me. Okay. Yes, we needed this one.
I want to
Okay.
do the parallel circuit.
So now we have the battery in here, as you guys can see. Now we need to add, to make a series circuit. To make a series circuit, we need only one path for electricity to move through, right?
Yes.
Now we need to add a bulb to it.
You need, Miss. I will
Yes,
show you what you need to put. You need to put
I needed to make
this
it
one,
longer.
these two.
Oh yes, but I need to make it a little bit longer. So I can
Okay, I
add two
did.
bulbs instead.
Okay, I
Okay, we'll
delete
put
it.
Miss,
this
you
one
may
here.
add this line, yes, and then this one.
Yes, see, now I made it a little bit longer.
Yes,
This
so
is
you can
And
more
put
then
the
we
bit.
need
light
this
bulb in the
one.
middle.
Miss, it's a bit wider.
Put the light bulb.
Yes, we need it so we can add two bulbs.
Light bulb.
Where is it? Two light bulbs. So what do we call this?
So my
The series or
This is this is serious. Serious.
yes, because we only have one path. Okay, thank you. Now let's draw another one. So we'll use the same things, but instead we're gonna change the position of the two bulbs. Now we can make it a little bit shorter. Okay, here it is.
Miss, it's a bit wider, but now you're making it more better.
Now I'm making it shorter, yes. Now we can add one pulp in here.
Yes, this is more better.
Yes, this is smaller because now we need it to be a little bit smaller. Guys, we have less than a minute.
Miss,
So
there's less than 1
and
minute.
you
Read
can
it
tell me
again?
if you have any questions. Okay, so I'm
Can
building
you
a
read
new one
it?
here.
I have a question.
Yes.
In the series,
Yes.
if you add no in typical electricity,
Mm.
the more you add batteries, the more the energy will be better with the volts.
Yes, the lighter it will be. It will be shiner and shiner. Yes.
Okay.
Okay, guys, so I'm sorry the meeting is ending. Do you have any questions before leaving?
No, but Miss, I am here in the Zoom
No.
meeting, okay?
Okay.
Yeah, Miss.
So thank you guys for today. Thank you for attending. Thank you so much.